In this session, we will discuss important SLA concepts of Simplyblock. In any storage solution, two separate SLAs are most important. First, data protection guarantees. What are my chances to lose data? Second, data availability guarantees. What is my uptime, the percentage of time I can access my storage? Further, SLAs concerns performance, namely average and tail, access latency, and throughput and IOPS guarantees. In Simplyblock, performance guarantees can be linked to a priority class within a storage cluster. As Simplyblock is software defined, guarantees can only be made in the context of an operations model and specific benchmarked hardware. However, some common assumptions can be made. As explained in earlier sessions, data is protected via an Erasure coding schema, which is defined by two parameters, provided a cluster creation time, NDCS, or shortly N, and MPCS. K defines the amount of concurrent failures tolerated without loss of data. Be reminded that you require at least N plus K plus 1 devices in a cluster. Now, in a data center controlled by the customer, if we exclude accidental deletion of data and data center disaster, the only reason why data can be lost permanently is a permanent drive failure. Any other software or hardware failure can be repaired, including replacement of hardware, with proper data center grade NVMEs. There is one failure in 20 million operating hours. This means that over the course of a year and a cluster with 50 devices, the probability of a data loss under the assumption of an average repair time of disk failure is 6 hours, which includes switching the hot pluggable disk and completing failure data migration, is 1 to 45 for K being 0, 1 to about 1, 2 million for K being 1, and 1 to several billion for K being 2. The probability depends on the amount of devices in a cluster. Therefore, depending on the criticality of data, the amount of devices, and the availability of backups, choose either K is 1 or K is 2. Also, consider that the availability is affected by the number of K. In addition to the number K, availability also depends on the total amount of nodes in the cluster. To tolerate K simultaneous node outages without impact NIO availability, it is required to have at least N plus K plus 1 nodes in the cluster. If you have less nodes in the cluster, K is 2 only. Impacts the probability of data protection, but not of unavailability, as you may need to sometimes maintain a node and need to shut it down for that purpose or restart it. Choosing K is 2 is better from the perspective of availability if you have enough of nodes available. Also, keep node maintenance windows short. If a node is to be removed from a cluster for a longer time, it is better to remove the node via the SBCLI remove command. This will migrate data from the node to other nodes. Also keep in mind that after restarting a node successfully, it will take a bit of time until the cluster regains full redundancy. During that time period in which data migration tasks are running, the cluster can interrupt I/O in some cases, even if the number of node outages is below K. For planned maintenance windows, ensure that data migrations are completed between node shutdowns. Also take into consideration that a single failed device on one node impacts availability of the cluster. For example, if K is 1 and a device has failed on node 1, a node maintenance or outage on any other node will cause I/O interruption. In the cloud, under the important assumptions of instant stop and termination protection, and excluding data center disaster and accidental deletion of data, data is only lost in case of an underlying hardware failure or forced instance hibernation. Reboots, whether intentional or forced by hardware issues or otherwise, do not cause loss of instance data. AWS unfortunately does not provide any information on instance availability, but it is likely to be in the range of 1 time in 10,000 operating hours. Under this assumption, and a recovery time of not more than 3 hours, the probability of about failure to protect data over the course of an entire year and a cluster with 10 nodes is 1 to about 3. 800 and 1 to 12. 7 million for K is 2. This is the durability of 99.99999% over the course of a year. Be reminded, always use termination and stop protection for production instances. Now let us have a look at the performance SLAs. It is possible in Simplyblock to set limits of the amount of IOPS as well as read or write throughput on a per logical volume and per pool basis. This means that those logical volumes and pools will be capped and cannot use more IOPS or throughput. However, for any cluster which is significantly over-provisioned in terms of IOPS or throughput, this is not a guarantee, but rather ensure that none of the hosts consuming storage can consume more. In order to understand a total amount of IOPS and throughput available from a cluster, benchmarking of the cluster is required. Benchmarking can be best done using the FIO utility under Linux. In the future, Simplyblock will add auto-benchmarking of clusters and total IOPS and throughput guarantees for certain priority classes. In addition, we currently provide a QoS service, which allows us to prioritize traffic on a per vol and per pool basis with regards to access latency. A priority class 1 can currently be assigned to LVols and pools. Any traffic from this class will be prioritized over traffic from the general class. This does provide a guarantee of average or maximum access latency in absolute terms, but it ensures that regardless of the total amount of IOPS in a cluster, prioritized traffic only competes with each other. To provide an example, if we test that the average access latency in a cluster with 10 devices is 250 microseconds, a certain amount of parallel I/O, example, a number of database journals, this access latency will be maintained for the same workload even if the cluster receives many more I/O of non-prioritized traffic.